In this video, we are discussing rate of change. So rate of change is as simple as it is the fraction or rate that we use to represent how a line is changing. Another word we will use for this is slope. Slope and rate of change are synonymous. Okay. So we will look at a few different ways to find rate of change. One of them is to identify it from a table. Rate of change is always going to be y's change over how x changes. Rise over run is another way we see this, okay? Now in tables, we're going to look at the change in y first, how we get from one to the next, and then we'll look at how x changes here momentarily. So from 13 to 17, I add 4. From 17 to 21, I add 4. Do we see the trend here? Plus 4, plus 4. So my numerator is going to be positive 4. For my change in x, which is my denominator, I add plus 2, plus 2, plus 2, plus 2. And then, of course, I'm going to simplify. I do want you to try to keep this in fraction form because it actually becomes very helpful when we start to graph something based on our slope or our rise over run or our rate of change. So the rate of change of this table is 4 over 2 or 2 over 1. For the next table, again, we're going to start with our change in y over our change in x. This symbol here, it's called delta. It's a Greek letter, and it represents change. Just for future reference, you'll see that a lot as the years progress in math. My change in y, I go from 3 to 11, which is plus 8. 11 to 19, plus 8. Do we see the trend? Plus 8, plus 8. And then for x, I get plus 2, plus 2, plus 2, and plus 2. So my change in y is 8, my change in x is 2, and I end up with 4 over 1, or just 4. Sometimes you will have tables that are not linear functions. We will talk more about what a linear function is later, but just to be clear, when we're talking about rate of change, we are focused primarily on linear functions at this point, and that means that it has a constant rate of change, meaning the numbers for y and x change consistently, okay? Now, they might not show consistently on a table. It could be a change in 4 and then a change in 2 and then a change in 6. But if it changes inconsistently for the y values, it should change inconsistently in the same way for the x values, and you should end up with the same unit rate each time, okay? Because remember, this is a unit rate showing the change in y over the change in x. So 20 to 16 is minus 4. 16 to 12, minus 4. 12 to 18, minus 4. So I'm going to have minus 4 on my numerator. My denominator, plus 5, plus 5, plus 5. So they all change in the same way. Okay, so my linear function's rate of change is negative 4 over 5. Now if you look at this nonlinear one, though, my change in y is plus 2, and then plus 6, and plus 10. So 2, 6, and 10. And then I have 2, 2, 2. So they all change with a different unit rate based on this. Oops, sorry, 5. And therefore this is not linear because it is not a constant rate of change. It doesn't change consistently. I did want to bring up points when you have 2 points and are asked for a rate of change, because while there is a formula that makes it somewhat simple to do this, and that formula for the record is y2 minus y1 over x2 minus x1. So basically the change in our y values over the change in our x values. The little 2's and the little 1's represent, like, this is equation number, or point number 1, and this is point number 2. But what is much simpler than memorizing this formula, although that does work, is to just make a little table out of this. Okay? So I have 3, 5 as one of my points, and negative 4, 5 as my other point. So I'm going to look at my change in y, which is 5 to 5 is plus 0, over my changes in x, which is minus 7, right? So we go from 3 down to negative 4, which is minus 7. And my change in y is 0. My change in x is negative 7. And then my slope is 0. But if you look at this, I could say 5 minus 5. So y2 minus y1, 5 minus 5. Over negative 4 minus 3. And that will get me the same end result. However, memorizing a formula, much less simple than just creating a table out of 2 points. One last example, creating a table with 2 points or using the slope formula. I'm going to start off with my table, and then I will show you the formula. So I have negative 4, 8, and I have 6, 7. And then I go from 8 to 7, that's minus 1. From negative 4 to 6 is plus 10. So I get negative 1/10 as my rate of change. y2 minus y1 over x2 minus x1 is my other option. I'm going to say this is point number 2, so I'm going to say 8 over negative 4 minus, this will be my y, y and x1, 7 over 6. Remember, y is always our second coordinate, and x is our first part of our coordinate. Okay? So 8 minus 7 is still 1. Negative 4 minus 6 is negative 10. They're both minus. So negative 4 plus negative 6, which is equal to negative 10. So I got the same answer either way. If you prefer the formula, go for it. If you prefer the table, that is an entirely valid option as well.